What if sleep isn't a retreat from the world, but a return to the stars? What if every time you closed your eyes, the universe opened hers? Not in dreams, but in remembrance, because your bones are echoes of collapsed suns, and your blood sings with the memory of hydrogen forged in the fire of first light. You are not falling asleep. You are re-entering the origin. The stillness you feel, it is not the absence of noise. It is the presence of everything that came before sound. So lay back, breathe slowly, and let the cosmos begin to remember you. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. Let the lights fade now. Let the room dissolve. Let your heartbeat sync with the slow rhythm of expanding space. You are about to drift through the greatest lullaby ever sung, one made not of words, but of gravity, light, and time. Imagine you are floating beyond Earth, beyond even the magnetic kiss of our Sunday. There is no wind here, no edge, just a black so deep it makes the idea of color feel like an ancient myth. Yet in this infinite dark, a trillion lights are born every second. And the most humbling truth? There are more stars in the universe than grains of sand on all of Earth. Pause, let that land. Picture it. Every beach, every desert, every particle slipping between your toes, every golden shimmer carried by the wind across time. Multiply them billions upon billions, and they still fall short. Because out there, in the quiet cathedral of the cosmos, stars are as abundant as breath, and each one is a story you've never heard. A blazing sphere of plasma, some cold and red, others blue and burning hot, each with its own system, its own family of planets, its own gravitational ballet. Some of them died before Earth ever formed, and yet their light is only now arriving. You are not looking at stars. You are looking at ghosts that never stop shining. This alone should make you shiver, not in fear, but in reverence. Because when you gaze into the sky, you are not seeing distance, you are seeing history. You are bathing in the ancient radiance of a universe that has never once stopped becoming. The cosmos is not a place, it is a process, and you are inside it. Let this idea sink in, like starlight on still water, that from a distance, a cosmic distance, even chaos looks like choreography. The swirl of galaxies, the clash of quasars, the birth and death of suns, it all moves in a kind of hush, a ballet so massive and slow, you'd need 1,000 lifetimes just to witness its opening act. But right now, you are here, alive, awake, or perhaps just beginning to sleep in the arms of infinity. Take a deep breath, slowly. You are inhaling atoms that were once part of a dying star. Carbon forged in stellar furnaces, oxygen breathed by ancient forests, hydrogen from the first moments after the Big Bang. You carry their legacy not metaphorically, but literally in your lungs, your blood, your bones. You are the dust of the universe, learning to speak, and that is not poetic exaggeration, that is scientific fact, a truth so intimate it borders on spiritual. As your thoughts begin to soften, let the boundaries blur. Let the noise of the world retreat like a tide. And know this, while you lay there in silence, galaxies are moving. The observable universe, the only part we can detect with light, is 93 billion light-years wide. But that's just the part we see. Beyond it, no one knows. Infinity doesn't blink. Out there are galaxies we will never see, not because they are gone, but because the light they emit will never reach us. The fabric of space itself is stretching, pulling them away faster than light can catch up. This is not imagination. This is physics, and it is quietly, endlessly, breathtaking. But you don't need to understand all the math. You only need to feel it. The truth of the cosmos isn't in equations. It's in what it does to your breath when you look up. It's in the way your chest tightens when you realize you are standing on a rock, spinning around a star, which is orbiting the center of a galaxy, which itself is racing through a web of dark matter toward a destiny unknown. It's in the realization that nothing you are was ever separate from it. So close your eyes, let go. Tonight, the universe will hold you, and not as a stranger, but as one of its own, because before you were a child of Earth, you were a child of stars. What if the edge of the universe isn't an edge at all? What if the limit of what we can see isn't the limit of what exists, but simply the distance light has managed to whisper across time? There is no wall, no border, no final curtain closing the stage. The universe doesn't end, it simply fades from view. And that fading is where the mystery begins. Because everything you've ever known, every planet, every star, every ancient galaxy ever captured by telescope, all of it fits inside a sphere 93 billion light years wide, a bubble of awareness suspended in an ocean of unknowns. We call it the observable universe. But don't be fooled. This is not the edge of the cosmos. It's just the farthest light has had time to travel since the beginning of time. Let's put that in perspective. Light, the fastest thing in existence, takes 8 minutes to travel from the sun to Earth. From the nearest star beyond that, 4.3 years. From the center of our galaxy, 27,000 years. But some of the galaxies we see through deep space telescopes, their light has traveled for over 13 billion years, arriving now, like a message in a bottle from a universe that barely knew how to form stars. And yet, due to the expansion of space itself, those galaxies are now much farther away than that, maybe 30, 40, even 50 billion light years distant. Their light left when they were nearby. But while it was en route, space grew and stretched the distance like fabric pulled across an endless loom. This is the paradox. The deeper you look into the past, the farther away those objects have become. The farther you reach, the farther they are. You see, the universe doesn't just sit still while you observe it. It grows, it breathes. It moves not like a balloon drifting through air, but like the balloon itself inflating, with galaxies as tiny dots painted on its surface. As the balloon expands, every dot moves farther from every other, not because they are traveling through space, but because space itself is growing between them. And so the edge of visibility, the limit of what light has reached us, is not a hard border, it's a horizon, a light horizon, a boundary drawn not by walls but by time. If the universe is 13.8 billion years old, then you might expect we can only see 13.8 billion light years in any direction. But the math of cosmic expansion adds a twist. Because the universe has been growing ever since it began, the true diameter of the observable universe isn't 13.8. It's over 93 billion light years, a staggering bubble of time and space surrounding you, right now, as you breathe. And beyond that, we don't know. Maybe it goes on forever. Maybe it loops. Maybe it folds in on itself like a Mobius strip, or births new universes with every quantum fluctuation. But whatever lies past our light horizon, we'll never see it. Not because it isn't there, but because its light has not, and may never reach us. These are not just poetic musings. These are equations scribbled into chalk on blackboards, tested by telescopes, simulated by supercomputers. Science that humbly admits its own limits. Because there is no spacecraft fast enough, no lens clear enough, to glimpse beyond that cosmic curtain. That's the great irony of discovery. The more we understand the universe, the more we confront what we cannot reach. And maybe that's the point. Maybe the cosmos was never meant to be conquered, only witnessed, to remind us that reality is bigger than certainty. That wonder is not just an emotion, it's a tool, a compass that points us not to answers, but to better questions. So here's a question worth sleeping on. If you could stand at the very edge of the observable universe, on the outer rim of what we can see, and look outward, what would you find? Not a wall, not a void, not the end. You'd find a place where the cosmic silence has lasted longer than light itself has existed. A realm so far removed in time and distance that even photons, the fastest travelers in the universe, have not arrived from there yet. You'd find darkness, but not emptiness, because space doesn't need to glow to exist. It can stretch, expand, evolve silently, invisibly, until the end of time. And make no mistake, it's still expanding, faster and faster. The very fabric of space is rushing outward, pulled by something we don't yet understand. Galaxies that are now visible will one day slip beyond our reach, not because they're gone, but because they've receded faster than their light can close the gap. And one day, perhaps in the distant far future, the universe will become a lonely place as distant galaxies vanish not with a bang, but with a whisper. So when you look into the night sky, know that you're looking at a shrinking archive of what once was. And yet, in that shrinking archive lies everything we know, every clue, every whisper of origin and fate. And that's enough, because you, floating on this fragile sphere of rock and breath and memory, have access to something miraculous, a moment of calm inside a universe of motion. And that calm, that stillness, it's not a contradiction, it's a gift, a place where the vast becomes intimate, where infinity fits inside the silence between two thoughts. You are not on the outside looking in, you are inside the universe, looking out at itself, and maybe, just maybe, that's what consciousness really island. What if the universe didn't explode into existence, but unfolded from a single note we've never stopped hearing? There was no bang in the Big Bang, no roar, no fireball bursting outward into empty space. There was no outward yet. There was no space for anything to explode into. There was no before, because time as we know it didn't exist. What happened at the beginning wasn't an event in time, it was the birth of time itself, a nothing that became something, a nowhere that became everywhere. And it didn't happen in space, it was space. Try to imagine a fire that burns without fuel, without air, without flame, a fire that doesn't scorch, but expands. That fire is still burning, and it is called existence. What we call the Big Bang is not the moment things began to move. It's the moment the very fabric in which movement could happen was born. It is the sudden appearance of space-time from a condition so alien, so unlike anything we've ever experienced, that our minds can only orbit around it, never land. Before the Big Bang, there was no empty blackness waiting to be filled. There was no black, no waiting, no distance, no rhythm. And then, in an instant so small it defies language, reality happened. From something unimaginably dense, not packed into a ball inside space, but as space the universe began to stretch, rapidly, relentlessly, in every direction at once, not into the void, but creating the void as it stretched. The rules we now call physics did not yet exist. Time had no seconds, space had no inches, temperature, energy, direction, all meaningless words, until that moment decided to give them meaning. This was not chaos. This was potential waking up. And then, a few 100,000 years later, a mere blink in cosmic time, something extraordinary happened. The light broke free. Before this, the universe was too hot, too dense, too wild. Photons, particles of light, couldn't travel more than a fraction of a millimeter without crashing into particles, scattering like wind through a forest of mirrors. But then, the universe cooled, the fog lifted, and light finally had room to roam. That first light still exists. It has never stopped moving, and it is all around you, a ghostly microwave glow from the infant universe itself. You can't see it with your eyes, but radio telescopes hear its whisper. It's called the cosmic microwave background, or CMB. It is the oldest light in the universe, not because it is the brightest, but because it is the most enduring. It is not a flash, it is a memory, a snapshot frozen in time, when the cosmos became transparent. It is the baby photo of everything, and hidden within its nearly uniform warmth, just a few degrees above absolute zero, are tiny fluctuations in temperature, no bigger than a millionth of a degree. Ripples, wrinkles, blemishes in the otherwise smooth face of creation. But those tiny imperfections, they were everything. They were the seeds of all structure, the blueprint for every galaxy, every star, every atom, every future love song and heartbreak and birth and death. The clumps of slightly denser energy in the early cosmos was sculpted by gravity into the web we now see stretching across billions of light years. The cosmic microwave background isn't just a remnant, it's a testament, proof that the universe was once young, and hot and small, and now is vast, cool, and ever expanding. And yet it's not cooling like a fire dying. It's stretching like a breath held in slow motion. The more space expands, the more the light stretches. Its wavelength grows, its energy fades. And in this stretching, we read the story of a universe in motion, not through a telescope alone, but through time itself. The Big Bang wasn't a bang, it was a becoming, and it is still happening. Every second that passes, every tick of your watch, every blink, every breath is a continuation of that first unfolding. The expansion hasn't stopped, the background radiation hasn't vanished. The fingerprints of that first moment are still pressed into the walls of the cosmos. And you are not outside of it. You are inside the echo. Your very atoms, carbon, oxygen, iron, were born in the furnaces of the first stars, whose birth was made possible by the conditions set in motion in that initial spark. So next time someone tells you the Big Bang was just a theory, remind them, you're breathing its evidence. You're made of its consequences. You are the Big Bang, just 13.8 billion years later, wondering what it all means. Let that settle. You're not in the universe. You are the universe, briefly aware of itself. The light you see from your bedroom window, the heartbeat pulsing in your chest, the feeling of stillness before sleep, all of it is connected to that ancient fire, a fire that still glows in microwave light, a fire that still stretches, cools, evolved, a fire that gave birth to stars, and one day gave birth to you. So close your eyes now, not in darkness, but in awe, because even here, even in silence, the story continues. What if the most important structure in the universe is something you can never see? We are taught to believe what we see. Light is our compass, our comfort, our guide. But the universe, in her oldest wisdom, whispers a truth far more unsettling. What you see is not what holds you together. Behind every star, behind every galaxy, behind every graceful spiral dancing through space, lies something dark. Not evil, not monstrous, just invisible. And yet, without it, everything would fall apart. Galaxies would spin themselves to pieces. Stars would be flung like sparks into the void. The elegant clusters we see scattered across the sky gone, shattered, disbanded. What holds them in place is something we do not understand. We call it dark matter, not because it's sinister, but because it does not shine. It does not glow. It does not interact with light at all. We only know it's there because of what it does, not what it shows. It pulls, it binds, it sculpts the galaxies. It weaves the cosmos into structure. It is the skeleton of reality. Look up at the stars tonight and realize, for every luminous thread you see, there are dozens more you do not. Hidden filaments of invisible matter stretching like bridges between galactic cities. Highways of gravity. Threads in a cosmic web spanning hundreds of millions of light years. This is not metaphor. This is what the universe looks like. The cosmic web, an intricate network of filaments, voids, and clusters, with dark matter as the scaffold upon which galaxies are strung like pearls on a necklace. If you could step back far enough billions of light years away, you'd see it. Not stars, not planets, but structure. Veins of gravity pulsing with ancient matter, filaments where galaxies grow, vast hollows where matter is almost entirely absent, a spider's web of space itself. And at the center of it all, nothing you can see, only what you can feel, because dark matter doesn't reflect light, it doesn't emit energy, it doesn't dance in electromagnetic waves, but it bends gravity, it distorts starlight, it holds galaxies like a gentle fist, tight enough to contain, loose enough to let them spin. Without it, stars in galaxies would move too fast to stay bound, like a carousel losing its center. They'd fly off into the abyss. But they don't. They stay, because something is holding them. We've mapped this invisible matter not by sight, but by gravitational lensing, watching how it warps the light from distant galaxies. The distortion is subtle, a slight stretch here, a gentle arc there, but consistent, measurable, real. In the quiet mouth of curved light, we find dark matter's fingerprint. Imagine watching a beam of starlight bend around something that isn't there, a ghost with gravity, a presence without presence. That is the paradox of dark matter. And yet, it outweighs us. Ordinary matter, the kind that makes up you, your breath, your home, the oceans, the stars, is only about 15% of all the matter in the universe. The rest is dark. We are the minority, the luminous exception in a shadowed cosmos. And here's the most haunting part. We don't know what dark matter island. We've built particle accelerators, buried detectors deep underground, launched satellites, and still, it remains hidden, unbroken, silent. Is it a new kind of particle? A fundamental force? A shadow of another dimension? No one knows. It doesn't collide. It doesn't decay. It doesn't shine. It simply holds. It's the gravity behind the galaxy, the tension in the strings of the universe's loom. And though it does not interact with light, it has shaped every cosmic structure since the beginning of time. Galaxies formed around it. Stars gathered where it gathered. Planets followed its whisper. And you stardust that dreams are here because of where dark matter allowed stars to be born. Let that settle. The invisible made the visible. The unseen gave birth to the seen. And maybe in some way that's always been true. Because the most important things, gravity, love, thought, memory, cannot be touched, only felt, only inferred by what they shape. Dark matter is the universe's way of reminding us. Not everything that is real can be seen. So tonight, as you lie beneath a quiet sky, remember, the stars you see are just the surface, like foam on an endless black sea. Beneath them lies a structure more vast, more ancient, more mysterious than anything the eye can behold. A web of silence, a skeleton of shadow, a universe held together by the unseen. And maybe that's what Faith Island, not belief without proof, but reverence for what cannot yet be fully known. Sleep now. The darkness is not empty. It is the foundation of everything that glows. What if the very thing holding the universe together can't be seen, touched, or measured, only felt by its absence? We live in a cosmos where the brightest objects, stars, galaxies, quasars, are just punctuation marks, flecks of light on a far vaster page. But the structure of that page, the canvas it's written on, that is invisible. The stars are not scattered randomly. They follow a hidden script, a gravitational choreography, written by something that does not shine, and yet it holds everything. It is not a force you've felt, not a particle you've seen, but without it, the universe would unravel. This unseen phenomenon is called dark matter, and it is not just an idea, it's a revelation, a shadow cast not by darkness, but by structure. It makes up 85% of all the matter in the universe, and yet it neither emits light nor absorbs it. It passes through ordinary matter like a ghost through walls, and still it leaves fingerprints. Not in light, but in motion, in gravity. We didn't discover it by seeing. We discovered it by what was missing. In the 1,930 seconds, astronomers noticed something strange. Galaxies were spinning too fast. Based on the mass, we could see stars, dust, gas. They should have torn themselves apart long ago, but they didn't. Something was holding them together, something more massive than all the light combined. Dark matter doesn't slow down stars. It keeps them from flying away. It doesn't swirl like smoke. It forms halos, vast, spherical regions of gravitational glue around galaxies. But this is only the beginning. Zoom out far enough, not just from a galaxy, but from all galaxies, and a hidden pattern emerges. The cosmic web, an immense structure stretching across billions of light years. A three-dimensional lattice of matter and energy. Galaxies are not spread evenly like sugar in coffee. They are strung along filaments, vast strands of dark matter, hundreds of millions of light years long, with great voids between them. If you could float beyond the edge of vision and look back, the universe would resemble a neural network, or the mycelium of a vast cosmic fungus, a brain, alive, pulsing. It is not chaos. It is a web, and we are caught inside it. Dark matter forms its scaffolding, Galaxies trace its filaments like dew along spider silk. Stars bloom in its gravitational crevices. Black holes dance in the wells it deepens. We don't observe dark matter directly. We map it by distortion through a phenomenon called gravitational lensing. When light from a distant galaxy bends around a massive, invisible halo, we see the curve like glass warping a distant flame. That bend is the shadow of dark matter's pull. It is both delicate and immense, soft as silence, strong as steel, and it doesn't just shape the present, it sculpted the past. The first galaxies formed where dark matter clumped. The earliest stars ignited in its gravitational embrace. The very chemistry that led to planets and life followed the pathways laid down by a substance we still don't understand. What is it? A particle? A field? A shadow from a parallel dimension? Every answer slips through our fingers. We have given it names: WIMPs, axions, sterile neutrinos, and built machines deep underground to listen for it, but it doesn't speak. It's as if the universe is guarding a secret at its very foundation. And maybe that's why it matters so much. Because dark matter is the reminder that not all that is real must be visible, that some truths exist in absence, that the architecture of existence itself might be carved not in light, but in the unseen hand behind it. So tonight, as you lay in silence and let the noise of the world recede, know that beneath that silence lies something deeper, a scaffold of mystery, a backbone of night. The stars are not scattered like seeds tossed into wind. They are arranged, strung along tension lines of ancient force, curved by the gravity of an invisible ocean. And you, a brief flare of thought and feeling, are moving through that ocean now, carried not just by biology or breath, but by a web that holds galaxies in its grasp. You are not adrift. You are woven, not just on Earth, but into the universe, because the universe does not float in space. It is space, and the space you move through is not empty. It's threaded with history, matter, force, and mystery. And even if you cannot see the thread, it holds you just the same. What if the universe isn't just expanding, but rushing away from itself, torn apart by a force we can't explain, can't stop, and might never truly understand? There is a pressure moving through the cosmos. Not a wind, not a shockwave, but something stranger, a silent, invisible acceleration. It isn't gravity. In fact, it defies gravity. It doesn't pull, it pushes. It is the opposite of everything we thought we knew, and yet it governs the fate of the universe. We call it dark energy, not because it's evil, not because it's dark, but because it is completely unknown, a placeholder for the greatest mystery in modern physics. It doesn't shine, it doesn't decay, it doesn't clump into galaxies or stars, but it makes up nearly 70% of everything in existence. You heard that right. All the stars, planets, black holes, gas and dust, the visible universe is just a tiny fraction of what is actually here. And dark energy is the overwhelming majority. So, what is it? The truth? We don't know. What we do know is that it's winning. Once upon a time, not long ago, cosmically speaking, we believed the universe's expansion was slowing down, that after the Big Bang flung everything outward, gravity would act like a brake. Maybe it would keep the universe coasting forever. Maybe it would pull everything back into a final collapse, a big crunch. But then came the discovery that changed everything. Two teams of astronomers in 1998 measured the light from distant exploding stars called supernovae and found something shocking. The universe isn't slowing down, it's speeding up. And the farther away something is, the faster it seems to be receding. Galaxies are not just drifting, they are accelerating apart, as if pushed by some hidden hand, a hand we cannot see, a force that no one predicted. This isn't just weird, it's revolutionary, because in all our equations, in all our models, gravity has only ever pulled. But now, something was pushing. Dark energy had entered the story not with a roar, but with the quiet shift of numbers on a cosmic scale, a whisper in the starlight. And it changed the ending, because if the universe is accelerating, then the cosmos will never settle. It will stretch, and stretch, and stretch, forever. Galaxies will drift beyond the cosmic horizon. Light will grow so redshifted it becomes undetectable. Star formation will slow. Black holes will evaporate. And eventually, in the most distant future imaginable, only silence will remain. An empty stage, with no actors, no audience, just the memory of motion, echoing across an ever-expanding void. This is the destiny dark energy offers, and yet we have no idea what it island. Is it a property of space itself? A kind of vacuum energy, where every cubic meter of empty space contains a tiny amount of latent force? Or is it something more dynamic? A field? A force? A flaw in our understanding of gravity? Some theories propose it's linked to quintessence, a hypothetical field that changes over time. Others suggest our entire understanding of space and time might be incomplete, that we're watching shadows on a wall, mistaking them for truth. Even Einstein, long before dark energy was discovered, introduced a cosmological constant into his equations, a fudge factor to keep the universe from collapsing. Later, he called it his greatest blunder. But maybe it wasn't a blunder at all. Maybe it was a premonition. Maybe dark energy has been hiding in the math all along, waiting for us to catch up. And here's the strangest part. The more space there is, the more dark energy their island. Because if it's tied to the vacuum, then every time the universe expands, it creates more of the very thing driving its expansion. A feedback loop, a runaway effect, a universe destined not just to grow, but to drift apart at the speed of nothing. Let that settle. This is not science fiction. This is measured, verified, observed, and it forces us to confront something we rarely consider. The future of everything is not guaranteed, not permanence, not warmth, not even memory. But here's the wonder inside the terror. You are here now, at a moment when the stars still shine, when galaxies still glow, when consciousness can still ask these questions. You are alive during the brief window of the universe, when it is visible, knowable, illuminated. In 1 trillion years, no new astronomer will see what you can. No new being will study the Big Bang. Its light will have faded. They will inherit darkness. But you were born in the light. And perhaps that's no accident. Perhaps that is the miracle. So what is dark energy? A force? A flaw? A future? Or maybe, just maybe, it is the universe's final lesson, that some truths cannot be held. They must be watched, felt, accepted. That mystery is not the enemy of science, it is its fuel. And that the greatest beauty lies not in the answers, but in the questions that never stop expanding, just like the universe itself. What if you've never been still, not for a single second, because the ground beneath you is flying through the galaxy at 500,000 miles an hour? Stillness is an illusion. Even now, as you lie still, breath slow, heart quiet, you are moving. You are not just spinning with the Earth. You are not just orbiting the Sunday. You are being hurled through the galaxy on a path so vast, so fast, so relentless it slips beneath the notice of your senses. The Milky Way is not a silent backdrop. It is a living, breathing spiral, and you are caught in its current. Right now, you are traveling at over 500,000 miles per hour. That's 140 miles per second without lifting a finger. Our solar system is orbiting the center of the Milky Way, a colossal spiral of stars, dust, and memory, and we make one full circuit every 225 to 250 million years. That means the last time we were in this part of the galaxy, there were no humans, no mammals, just dinosaurs and stars. Our journey is called the galactic year, and you are mid-chapter in your first revolution. But the Milky Way is not a flat record spinning in the dark. It's a warped, rippling disk, bent by unseen forces, tugged by neighboring galaxies, swirled by ancient collisions. It is not static. It is a storm, a spiral galaxy of over 100 billion stars, arms stretched like glowing brushstrokes across the black canvas of night. We live in one of those arms, a quiet neighborhood called the Orion Spur, between two grand spiral arms, like a treehouse tucked between highways of starlight. From here, the Milky Way is hard to see. We're inside the forest, looking between the trees. But if you could rise above it, you'd see a radiant whirlpool of light, spinning through space like a giant cosmic rose. And yet, even this rose is moving. The Milky Way itself is on the move, drifting toward its sister, Andromeda, at over 250,000 miles per hour, a slow, majestic collision that will unfold over the next 4 billion years. The two galaxies will meet, not in violence, but in an ancient gravitational embrace. Their stars will mostly pass each other without ever touching. The spaces between them are so vast. But gravity will do its work. They will spiral. They will merge. They will become something new. A single, larger galaxy. A cosmic city reborn. And we, or whatever life may exist then, will be part of that merger. Not destroyed, but rearranged. Transformed. In the galactic dance that never ends. Because galaxies are not static islands. They drift. They collide. They grow. And the Milky Way has done this before. Look closely, and you'll find streams of stars, rivers of light flowing through our galaxy's halo. These are remnants of smaller galaxies long ago swallowed. Their stars now repurposed into the Milky Way's growing body, cosmic inheritance. Even now, we are absorbing tiny galaxies, pulling them in with gravity, folding their stars into our own. This is what galaxies do. They feed, they evolve, they remember not in memory, but in structure, in scars, in spin, and what holds it all together, this spinning wheel of dust and fire. At the center of the Milky Way lurks a supermassive black hole, millions of times the mass of the Sunday. Invisible, silent, immense. It does not devour the galaxy, it anchors it. Everything orbits around this shadow, even the Sunday. Ever new, this is your home, not your planet, not your continent, not your city, but this spiral of stars. You are not separate from it. You are a strand in its rotation, a mote of thought carried on its current, a flicker of awareness inside its turning wheel. And when you look up at the stars, you're not looking out. You're looking through arms of gas, through trails of ancient light, through corridors of dust older than Earth itself. Every night sky is a window into your galaxy. Every constellation a page from its autobiography. And when you look long enough, you don't just see stars, you see motion, because even the light is on a journey. It left those stars years ago, decades, centuries, millennia, and only just now, it lands on your eyes. You're not seeing the Milky Way as its island, you're seeing it as it was, which means, in some way, you are time traveling every time you look up. Let that settle. Right now, in the space above your ceiling, above your roof, above the clouds, the galaxy is spinning. The arms of the Milky Way stretch and twist, dragging stars in their orbit. Comets fly, clouds collapse into stars, supernovae flash, planets are born, moons drift into place, and all of it is happening with you in it. You are not drifting aimlessly. You are riding the spiral. You are moving with your ancestors. You are moving with unborn children. You are moving with whales and volcanoes and satellites and songs and love and longing. All of it, every moment of life, moving together inside a galactic tide. The Milky Way is not distant. It is home, and home is moving, fast, silently, forever. What if the brightest lights in the universe are born from the darkest hearts? Imagine a lighthouse. Now imagine it not on the coast of some earthly sea, but floating in the vast black ocean of the early cosmos, shining across billions of light years. Now imagine that lighthouse is powered not by flame, but by destruction, that its brilliance comes not from peace, but from chaos, from gravity, from hunger. This is a quasar, a cosmic contradiction, a paradox that glows. It begins with a supermassive black hole, millions, even billions of times more massive than the sun, sitting at the center of a galaxy, not silent, not dormant, but feeding. Gas, dust, stars, even entire solar systems, all drawn inward by gravity, spiraling faster, compressing, heating, colliding. A storm of energy so violent, it ignites. Before anything crosses the black hole's event horizon, the point of no return, it forms an accretion disk, a swirling, blazing ring of matter spinning at nearly the speed of light. Friction ignites it, magnetism twists it, gravity unleashes it, and the result? A beam of light so bright, it outshines the entire galaxy around it. These are quasars, quasi-stellar objects, first mistaken for stars because of their intense point-like brightness. But they are no stars. They are entire galaxies burning from the inside. And the light we see from them? It is old. Some of the quasars we observe are over 13 billion light-years away. That means their light left shortly after the Big Bang, when the universe was young, hot, and chaotic. These are the flares of infancy, the universe's first scream. It's proof of life. When we detect a quasar, we are peering into deep time, watching black holes grow at a time when galaxies were still assembling themselves from clouds of hydrogen. And here's the paradox that makes you pause. Black holes do not shine. They swallow light, they bend it, they hide it. But the matter falling into them, it shines with a brilliance beyond comprehension. So the most luminous objects in the universe are built around something utterly black. Let that sink in. Brightness born from darkness, energy born from gravity, creation born from collapse. And we found thousands of them scattered across the distant sky, like cosmic campfires, still burning after billions of years. Some of them radiate more energy in a second than the Milky Way emits in a year. We call them active galactic nuclei. We call them monsters. We call them mysteries. But they are also messengers. Their light passes through vast stretches of space, and in doing so, it carries the fingerprints of everything it touches. The gas it encounters, the galaxies it passes, the expansion of space itself. We use quasars to measure the universe, to map its history, to study the intergalactic medium, the thin, invisible gas between galaxies that quasars illuminate like street lamps on a foggy road. They teach us about the early universe, about how fast it was expanding, about how black holes grew, about how galaxies fed themselves. They are ancient witnesses still whispering across the void, and there's something almost spiritual about that, isn't there? That light, real light, physical photons left a quasar over 13 billion years ago, before Earth existed, before our sun had formed, before atoms in your body had come together. And that light traveled, undisturbed, unbroken, across time, across space, across expansion and void and vacuum, to reach you. Now, tonight, in this breath, you are the destination of ancient light. You are its landing place, a being of carbon and thought, receiving a message from a black hole that lived and died before your species ever dreamed of fire. What does that make you? A witness? A vessel? A spark? Maybe all of them. Maybe that's what consciousness is, not a trick of biology, but a mirror for light that has wandered for eons. Quasars are more than scientific curiosities. They are the proof that even the most destructive forces can birth unimaginable brilliance, that even collapse can create light, that even a black hole, the symbol of cosmic death, can become the engine of illumination. So next time you feel small, remember, you are made of atoms forged in stars. You orbit a sun inside a galaxy. That galaxy spins inside a web of dark matter, and all of it moves through a universe where quasars still shine across billions of years, just to remind you that something once burned so bright, it reached across time itself. And you are here to see it. What if everything you've ever seen, every planet, galaxy, cloud, and dream, was once smaller than a single atom, and became the universe in less than a trillionth of a second? There is a moment too small to measure, too fast to remember, too early to record, when everything changed. A moment when the universe didn't grow, it erupted, not with fire, not with sound, but with space itself stretching, blooming, unfolding faster than light, faster than thought, faster than the word fast can contain. This was inflation, the first movement. The breath before time began to count. To understand inflation is to stare into a miracle that's not metaphor, it's physics. In the first 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 What does that mean? It means that a region smaller than a proton stretched to the size of a galaxy, that distances smaller than thought suddenly became space, that emptiness was filled not with matter, but with possibility. And here's the paradox. Nothing traveled faster than light, but space itself did. You see, the speed of light is a limit, but only for things moving through space. Space itself has no such leash. It can grow as fast as it wants. And during inflation, it did. This is not a metaphor. It's the best model we have for how the universe took shape. But what caused it? We think a mysterious energy field filled the early universe, a kind of inflaton field whose potential energy suddenly released, driving this exponential expansion. Why did it end? We don't know. But when it did, when inflation stopped, it released a tsunami of heat, energy, and structure. That moment is what we usually call the Big Bang, not the start, but the aftermath of inflation. In this roiling new cosmos, quantum fluctuations tiny, random jitters in energy were stretched across the fabric of space. And those tiny jitters? They became everything. Where energy was slightly denser, gravity pulled harder, matter collected, galaxies formed, stars ignited, planets spun. You are sitting here today conscious, breathing, wondering, because of ripples in a quantum field that were magnified by inflation to the scale of entire galaxies. In other words, the very structure of the cosmos, the great web of matter and void, is a fossil record of quantum noise from the universe's first instant. Let that land, the lumpiness of galaxies, the filaments of stars, the very texture of reality, all began as randomness at the smallest possible scale, and inflation stretched it into structure. This is the moment the universe chose its shape, not with a blueprint, but with chance. And that chance became destiny. Some see chaos in that, but maybe it's something more elegant. Maybe it's the proof that order and randomness are not enemies, but partners dancing in the birth of everything. We have evidence for this. The tiny temperature differences we see in the cosmic microwave background, those slight ripples of warmth and cold, are the fingerprints of inflation. They match the patterns inflation predicts. Their randomness isn't random. It's patterned chaos, exactly what inflation would leave behind. It's like listening to a thunderclap and being able to map the entire storm that caused it. We cannot see inflation itself, but we see its wake. And here's what's even stranger. Inflation may not be a one-time event. Some theories suggest it could happen again, or maybe happening elsewhere, even now. Tiny patches of space-time, still inflating, birthing entire universes of their own. A multiverse, not in science fiction, but in mathematical probability. Each bubble with its own laws of physics. Each universe with its own constants. Each cosmos, a verse in a song too vast for us to sing. And we are just one note, one harmony, in a chorus beyond comprehension. This is not the end of science. It is the beginning of wonder, because inflation doesn't just explain where the universe came from. It expands what we mean by universe at all. It says, what you see is not all their island. It says, creation may not be rare. It says, the rules you cherish may be local, not universal. And in that uncertainty, we find a new kind of truth. That existence itself is more generous than we dared believe. So tonight, as you drift between thoughts, know this. You are lying on a planet that formed from atoms forged in stars. Stars born from galaxies shaped by gravity. Gravity sculpted by fluctuations. Fluctuations stretched by inflation. Inflation triggered by laws that may themselves have come from somewhere else. You are part of a story that began before time had meaning, and you carry the ripples of that first breath in every cell, every heartbeat, every quiet moment between stars. Sleep now, not in stillness but in motion, not in darkness but in expansion, because even in your dreams, the universe continues to grow. What if there was a time when light didn't exist not just as absence, but as a concept that hadn't been invented yet? There was a time when the universe was blind, No stars, nor galaxies, no flickers in the black, only the afterglow of the Big Bang, fading like a dying breath in a cathedral of infinite dark. It was a time of waiting not measured in seconds or centuries, but in silence. This was the cosmic dark age, a span of hundreds of millions of years when space itself had cooled, hydrogen had formed, but no light yet pierced the veil. There was no structure, no stars, no observers, only clouds of invisible hydrogen drifting through the endless dark. And then something stirred. Gravity began its quiet work. Clumps of gas collapsed. Pressure built. Heat rose. The first nuclear fires kindled not with matches, but with mass. And just like that, the universe awoke. The first stars were unlike anything we see today. Colossal, untamed, primordial. These were population 3 stars, forged entirely from hydrogen and helium, the only elements born in the Big Bang. There was no carbon, no iron, no metals to cool the gas. So they burned hot and fast titanic beacons, some hundreds of times the mass of our Sunday, and they roared. In their cores, nuclear fusion transformed simplicity into complexity, hydrogen into helium, helium into heavier elements. The first alchemy, the first forging. For the first time since time began, the universe had light. Imagine it, a black canvas, untouched for eons, suddenly split open by the scream of blue-white light from 1,000 newborn suns. The darkness was no longer safe. It could no longer pretend to be all there was. Light had found it, and it would never be the same. But it didn't stop there. These first stars didn't last long, a few million years, at most. They lived like cosmic firecrackers, burning bright, dying young. And when they died, they exploded. Supernovae. The first violence, the first brilliance. These titanic deaths scattered the elements they had forged: carbon, oxygen, iron across the cosmos, seeding the void, preparing the universe for everything that would come next. Without those first stars, there could be no planets, no life, no you. You are here because something exploded billions of years ago, far from here, far from now. But that's not the only miracle. As their light spread, it did something extraordinary. It changed space itself. For during the Dark Ages, hydrogen atoms filled the universe, neutral, invisible, quiet. The high-energy light from these first stars began to ionize that hydrogen, stripping electrons, making it transparent. We call this the epoch of reionization, the moment the fog lifted, the moment the universe became seeable. Before this, light couldn't travel far. It was blocked, absorbed, muffled. After this, light could roam freely. The universe became a window, not a wall. And now, thanks to telescopes that see far into the infrared, like the James Webb Space Telescope, we are finally glimpsing these first chapters. We are seeing galaxies formed just 300 million years after the Big Bang. We are staring into the eyes of ancient suns long dead, but still singing in the light they left behind. And what we find is beautiful chaos. Tiny galaxies colliding, starbursts igniting like fireworks, black holes already growing in the shadows. It is a cosmos discovering itself, messy, radiant, alive. There's something deeply poetic about this moment. That light had to fight to exist. That darkness wasn't defeated in an instant, but peeled back layer by layer. And that even now, the echoes of that dawn still ripple through the stars above you. When you look at the night sky, you're not just seeing stars, you're seeing a declaration. That light can rise in the deepest silence, that from hydrogen and gravity, two of the simplest forces, can come fire, that even the coldest universe can find a way to burn. And in that fire, possibility, because every element in your body, the calcium in your bones, the oxygen in your lungs, the iron in your blood, was born in a star like the ones that first broke the darkness. You are not separate from the cosmos. You are the voice it gave itself when it finally became bright enough to see. And maybe that's what the cosmic dawn really means. Not just the birth of light, but the birth of meaning. The first moment the universe began to tell a story, and you are the continuation of that tale. So next time you look up, and the stars feel still and quiet and far. Remember, they are ancient words, and you were built to understand them. What if the universe was singing all along, but we only just learned how to listen? Space is not empty. It stretches, it bends, it ripples, not metaphorically, physically. The very fabric of space-time, the invisible stage upon which reality plays its part, is not rigid. It sways, it flexes, it can tremble under force, and when it does, it sends gravitational waves echoing outward like ripples across a vast cosmic lake. These aren't sound waves. They're not light. They're not matter. They are pure geometry, in motion. A star collapses into a black hole. Two neutron stars spiral and crash. A pair of black holes collide with unimaginable violence. And across the darkness, across billions of light years, those cataclysms send out gravitational waves, faint and furious, traveling at the speed of light, carrying with them not energy, but information about the most violent events in the cosmos. But here's the miracle. They don't move through space. They are space in motion. A gravitational wave doesn't pass by you. It passes through you, stretching the very dimensions of your body, your atoms, your time. You don't feel it because the effect is so small, a fraction of a proton's width, but it's there, real, undeniable. For over a century, Einstein's equations predicted them, but for 100 years, we lacked the ears to hear them. That changed in 2015. In a quiet room on Earth, after decades of failure, a signal arrived at the twin observatories of LIGO, the Laser Interferometer Gravitational Wave Observatory. It wasn't a light, it wasn't an image, it was a tiny chirp, a blip in space-time, the final breath of two black holes spiraling into one another, 1.3 billion light-years away. We had heard the universe move. Think about that. The event took place before humans ever walked the Earth, before trees existed, before dinosaurs, and yet we caught its signal now, because space-time never forgets. It was the moment humanity became not just stargazers, but wave listeners. And since then, we've heard dozens more, neutron stars crashing, twisting space-time like a storm, black holes merging, ringing the universe like a drum, ripples from the birth of structure itself. Gravitational waves are the heartbeat of creation. They don't scatter or absorb like light. They don't get blocked by dust or drowned in background radiation. They pass through everything, which means they carry stories. Light cannot tell of the dark, the dense, the hidden. They are the voice of what was once invisible. And the poetry of it? These ripples aren't just from the past. They are the past, arriving in the present. You sitting in your room, breathing in silence, are being touched by events that happened before Earth had continents. You are, right now, bathed in the memory of cosmic violence. And it is gentle, and it is real, but we are only at the beginning. Soon, new detectors will rise. LISA, a gravitational observatory in space arms millions of kilometers long, listening to lower frequencies, slower dances, supermassive black holes, orbiting each other like titans in slow motion. We'll hear waves from the early universe, possibly even from inflation itself. We'll hear the first breath of creation, not in light, but in motion, and it will change everything, because gravitational waves aren't just signals, they're language. They are how the universe tells us its secrets when words, light, and particles fail. They are the shudder of space-time under pressure, the breath between moments, the hum of existence, and the beauty. We now know the universe is not silent. It's been singing all along. We just weren't listening. And what we've heard so far is just the overture. More is coming. Deeper tones, richer harmonies, the slow roar of ancient giants. And perhaps, if we listen well enough, long enough, we'll hear something even stranger, a new kind of message, a code, a pattern that doesn't just describe the universe but explains why it is the way it island, maybe even why we're here to listen. So next time you're lost in thought in silence, know this. The silence is alive. It ripples with stories. And those stories are etched not in stone, not in light, but in the very geometry of time itself. What if the universe took a single photograph once, long ago, and everything we've ever known is hidden in its pixels? Before the stars, before the galaxies, before even the first flickers of light pierced the darkness, there was glow, a uniform, relentless fire, not of stars, but of existence itself. For the first 380,000 years after the Big Bang, the universe was an opaque ocean of plasma, hot, dense, white-hot with energy. Matter and radiation were tangled in an intimate dance, constantly colliding, scattering, reshaping one another. Light couldn't travel. It couldn't even think of escape. It was trapped in a prison of electrons, endlessly bouncing. But as the universe expanded, it cooled. And finally, one day, a very specific day, it crossed a threshold. Atoms formed, the fog lifted, and light was free. This was the moment of decoupling, when photons were no longer bound to matter. They scattered one last time and began their journey across the cosmos. That light, the very first to roam free, is still with us. We call it the cosmic microwave background, CMB. It is the universe's baby picture. It is not what came before. It is the moment the cosmos became visible, a canvas of frozen fire, stretched over space and time. You can't see it with your eyes, it's been redshifted down into the microwave part of the spectrum, but it is everywhere, in every direction, all around you. Right now, turn on a television to static. A tiny fraction of that noise is the CMB whispering across the ages. In 1965, it was discovered by accident, two engineers, Penzias and Wilson, trying to get rid of what they thought was interference from pigeon droppings in their radio telescope. But what they found instead was the echo of creation, an afterglow, not from a corner of space, but from the entire cosmos. It is the oldest light we can detect, not reflected, not emitted anew, but the original glow, the breath of the infant universe. And what it shows us is breathtaking. The CMB is astonishingly uniform, the same in every direction, to 1 part in 100,000. But those tiny variations, that faint unevenness, they are everything, because those are the seeds, the first tiny wrinkles of density that would eventually grow into galaxies, stars, planets, and life. From quantum fluctuations, smoothed and stretched by cosmic inflation, the entire architecture of reality was written into the sky. And we've mapped it with satellites like COBE, WMAP, and Planck. What they gave us isn't just a picture, it's a time machine, a glowing sphere surrounding us in all directions. Not because we're at the center, but because it's the oldest shell of light we can possibly see. Every observer, no matter where in the universe, sees themselves surrounded by it. Not because we are special, but because light travels at a finite speed. This image, this sphere of fire, is not a thing we look at. It's a thing we look through. And what it reveals is a cosmos that is not chaotic, but ordered, not random, but legible. A universe that followed laws, even in its infancy. It confirms that space is flat, that the universe is expanding, that dark matter shaped its early scaffolding, and that dark energy now stretches it toward an unknown future. All of that from a glow that's billions of years old. The CMB is a cosmic fingerprint, a frozen scream of the newborn cosmos, and the silence it rides upon speaks volumes. Because light is not eternal, it fades, it redshifts, it thins into nothing. But this light, this whisper persisted, and by studying its fluctuations, its power spectrum, its delicate geometry, we can test ideas about the earliest moments of everything. Was the universe born from inflation? Did it arise from a singularity? Are there clues to other dimensions hidden in those waves? We don't know yet, but the CMB holds the keys. It is the Rosetta Stone of cosmology, a snapshot of the moment the lights came on, still echoing in the shadows of time. And maybe the most humbling part? This light, this pale, fading glow has been touching us since before there was an earth to touch. It passes through you as you read this. It hums through your bones. It sings in your microwave. It is the first lullaby the universe ever sang. And though we now fly telescopes into space, build machines of staggering precision, and measure the cosmos with digital perfection. This signal, this light came first. It didn't wait for us. It didn't need us. But it held its breath across eons, just in case someone might come along and listen. And we did. We looked up. We tuned in. We saw the face of the infant universe not as myth, not as metaphor, but as light, printed across time. And in doing so, we learned that we are not just passengers in the universe. We are part of its unfolding memory. What if the farther you looked into space, the deeper you were falling into the past? Imagine standing in a dark field at night. You look up. You see stars, galaxies, perhaps a faint smear of the Milky Way. You think you're seeing space, but what you're really seeing is time. Light takes time to travel. When you look at a star 100 light years away, you're not seeing it now. You're seeing it as it was 100 years ago. Push that idea further to 1,000 light years, a million, a billion. Eventually, you hit a wall not of matter, but of time delay. It's called the cosmic horizon, the maximum distance from which light has had time to reach us since the birth of the universe. Roughly 46 billion light years in every direction. But wait, didn't the universe begin 13.8 billion years ago? Yes, and here's the twist. Because space itself has been expanding, the most distant galaxies we can see now are much farther than 13.8 billion light years away. They emitted their light long ago, but the space between us and them has stretched since then. Space isn't just a stage on which the universe unfolds. It's a character in the story. And it's not passive, it's growing. Every second, galaxies drift farther apart, not because they're moving through space, but because the fabric of space itself is expanding. Imagine dots on a balloon. As you inflate it, the dots spread apart. No dot is the center. The balloon itself, the space between, is growing. Now, stretch that into 3 dimensions. Now add time. This is your universe. And here's the mind bender. There are galaxies we will never see, not because they don't exist, but because the space between us and them is expanding faster than light can bridge the gap. Their light will never reach us. They are beyond our event horizon, not in the black hole sense, but cosmologically. They are outside the observable universe, falling away into a future we can never witness. And every second, more galaxies cross that threshold. Every heartbeat, more of the cosmos slips out of view. The observable universe is not the whole universe. It's just the part we can see, a shrinking bubble of cosmic memory, bordered not by matter, but by the speed of time itself. And the cause? 2 words: dark energy, a force or property embedded in the vacuum of space, pushing galaxies apart with accelerating momentum. We don't know what dark energy island. It's not a thing, not like particles or fields. It's a pressure, a stretch, a whisper in the void, telling everything to pull away. It means that over time, galaxies we can see today will drift out of view. The night sky will darken. Civilizations in the far future may look up and see only blackness, a lonely island of stars surrounded by nothing. They may never know there was a big bang. They may never guess they were part of something vast. Because cosmic history is not just about what happened, it's about what remains visible. And the horizon? It's not fixed. It's not a wall. It's a limit defined by time and acceleration, a frontier where space grows faster than light can catch it. It bends logic, it mocks scale, and it means this: there are parts of the universe so far away, their present is already our never. And you are right at the center, not because you're special, but because every observer island, the horizon surrounds you in all directions. It's not a privilege, it's a consequence of how light works. You live inside a bubble of perception, shaped not by space, but by time's speed limit. And when we map that bubble, we find galaxies smeared across billions of light years, each one frozen in an earlier version of itself, like postcards mailed long before we were born. But here's the awe. Even as the horizon slips outward, we can still trace the story. We can measure redshifts, the stretching of light waves due to expansion, and know how far, how fast, how long. We can see ancient galaxies, born when the universe was only a tenth its current age. We can witness the universe growing up a time-lapse in reverse. And it teaches us one final lesson, that space and time are not separate. They are the same thing, a single fluid called space-time, which curves, stretches, breathes. In the earliest moments, space grew faster than the speed of light, inflating from subatomic to cosmic in a heartbeat. And today, space still expands not from a central point, but everywhere, equally. The cosmos has no edge, only a limit to what can be seen. And beyond that, we don't know. There may be infinite galaxies, infinite variations, even infinite U's, scattered across regions of space-time forever beyond your reach. But right now, in this moment, you are looking across the past of everything. You are watching space become time. You are surfing the skin of the visible cosmos. And as the universe expands, so does your perspective. Because the ultimate edge is not out there. It's the boundary of your imagination. And that is infinite. What if the universe isn't just made of matter and energy, but of awareness itself, slowly waking up through us? Let's pause. Step back from particles, galaxies, wave functions, and red-shifted light. Close the textbooks, quiet the data, and ask the forbidden question: who or what is doing the looking? For all the precision of physics, for all the charts of expansion, the equations of entropy, the satellites measuring the flicker of ancient photons, none of it means anything without a witness. None of it exists in any real way without a mind to observe it. And somehow, miraculously, impossibly, that mind is you, a fleeting bundle of neurons, a tangle of perceptions, a small, fragile flame of self-awareness, adrift in cosmic ocean. But here's the paradox. You, made of carbon, forged in a star, are now contemplating the star. You, a ripple in the universe, are now reflecting on the sea itself. This is the observer's loop. The universe gives rise to conscious beings who then turn around and observe the universe. The mirror reflects the mirror, and what gazes back is not just data. It is wonder. It is awe. It is a sensation that something deeper is unfolding, that behind the particles and photons, something knows. Science has never fully explained consciousness. Neuroscience maps the brain, but can't touch the subjective feeling of being you. Physics models the world, but collapses when no observer is defined. Some interpretations of quantum mechanics say that observation creates reality, that a particle doesn't become real until it is measured. Others scoff. They say consciousness is just an emergent glitch, a side effect of biological machinery. But even they must admit, without consciousness, the universe is a dark, silent void. With it, the cosmos begins to mean something. This tension has haunted mystics, philosophers, and physicists alike. Einstein said, "I want to know God's thoughts, the rest are details." Max Planck, father of quantum theory, believed consciousness was fundamental. And even today, physicists ask whether space-time itself might emerge from entangled information, perhaps even from observation. What if the universe is more like a dream than a machine? What if reality is not out there, but in here, shaped not just by forces and laws, but by perception itself? You, after all, don't experience atoms and equations. You experience color, sound, emotion, presence. You experience a story. And this story, your life, is being told by something that didn't exist 1 billion years ago, but that the universe labored for eons to bring forth. Maybe that's the point. Not to know the cosmos, but to feel it, to be so overwhelmed by its beauty, its terror, its incomprehensible vastness, that for a moment you fall silent, and in that silence you touch the fabric of the real. Carl Sagan once said, "We are a way for the universe to know itself." But maybe it's deeper. Maybe we are the universe dreaming, a fleeting thought in a cosmic mind, trying to remember its own name. All those galaxies? They aren't just distant. They are metaphors. They are reminders that you are not small. You are rare, a self-aware fragment of a reality so vast. It needed 13.8 billion years to create the conditions for you to ask this question. Why am I here? And maybe, just maybe, The answer isn't out there. Maybe it's in the asking itself. So what do we do with this? We wonder, we imagine, we share, we reach out into the dark and light a spark. Because no matter how many equations we solve, no matter how much sky we map, no matter how many theories we construct, there will always be mystery. And maybe that's the gift. Maybe we weren't meant to conquer the universe. Maybe we were meant to fall in love with it, to become its eyes, its voice, its question, and maybe someday, its answer. You are stardust. Yes, but you are also the dreamer of stardust. And the universe? It's still dreaming. Through stars, through gravity, through time, through you.